you ever been really cold? What about negative 460 degrees Fahrenheit? Probably not. Because at negative 460 degrees Fahrenheit, it was originally believed that it's absolute zero, and it's originally believed that all the atoms in your body would stop moving. So you'd be completely frozen. So, but then as we moved on in time, we realized that that doesn't happen. It doesn't make your volume zero, is what the actual, like, science term for it is. But, what it actually is cryogenic gases, and what they are is a liquid state of things below 190 degrees Fahrenheit. And cryogenics is how to get things to a cold temperature and how they react when they get there. So, with dry ice only gets things to negative 80 to negative 100 degrees Fahrenheit. So those, whatever you can, what gases you can liquefy with dry ice isn't a cryogenic gas. It's just a liquefied gas. So originally there was six, or there still is. There's six things that you can't that are classified as cryogenic gases because they don't liquefy until after 190 degrees Fahrenheit. Some common ones are like liquid nitrogen. It gets to temperatures of negative 300 degrees Fahrenheit and below. We use that for cryopreservation, which is where you're storing organs, sperm cells, embryos, stuff like that, and you can store it almost indefinitely. Another thing that we use is liquid helium, which gets to negative 452 degrees Fahrenheit, only 8 degrees away from absolute zero, and that's when helium liquefies. And we use that to supercool magnets for MRI systems in hospitals. Right here, I have a little timeline, and what it is in 1845, English physicist Faraday, he was the one who used dry ice, and he liquefied all the different states, all the different gases besides six. It was oxygen, hydrogen, nitrogen, carbon dioxide, and methane, and nitric oxide. And then in 1877, there's a few droplets of liquid air. And then in 1883, there was the first measurable unit of liquid oxygen instead of just a few drops. And then in 1845 to 1888, we discovered the actual temperatures of which oxygen and nitrogen freeze at, or liquefy at. Oxygen is negative 297 degrees Fahrenheit. Nitrogen is negative 320 degrees Fahrenheit. In 1898, we discovered that a liquefying hydrogen is at negative 400 degrees Fahrenheit. And then finally, in 1908, a Dutch physicist liquefied helium at temperatures of negative 452 degrees Fahrenheit. And this is a picture of, this is 1 milliliter of liquid helium. And what we're doing is dropping it into this would be like a little cup. And there'd be some magnets in there. And this is the process of supercooling a metal. And that's supercooling a metal. And this isn't cryogenics, but it's an example of compressing a gas. So that's what they do. They just take a gas and keep compressing it until it turns into a liquid. And then, we've all known about freezing people and making it to where you can store them for later and then bring them back later. Well, that's that's not cryogenics. It's cryonics. And cryogenics doesn't look at that as a branch of their science because it's never have any provable facts. It's never really succeeded in anything. So that it's not that. But what cryogenics really ultimately is the use for medical and industrial, because the MRI systems and they use it for cutting tools and industries, and so cryogenics is just getting a gas to a low temperature and then seeing how it acts when it gets there.